Excellent. All right. Hi, everybody, and welcome to this talk on SOAFEE-based software-defined vehicle deployment for autonomous driving. The work done in this presentation is mainly a collaboration between SOAFEE and the Autoware Foundation. Let me start by presenting Christian and myself. So Christian John is the president at Tier 4 for North America, and also the chair of Strategic Planning Committee at the Autoware Foundation. And myself, my name is Kasper Ornstein Mecklenburg from ARM, and I'm a performance analysis engineer, and I lead the Autoware OpenAD Kit blueprint in SOAFEE. So let's start by taking a look at today's agenda. So the agenda today is short and sweet and full of goodies. So I'll start talking about SOAFEE blueprints and EWAOL, and then Christian will take over and talk about Autoware Foundation, Autoware, and OpenAD Kit. So with no further ado, let's jump into SOAFEE blueprints. So the SOAFEE blueprints is an initiative driven by our members to materialize the concepts behind our vision of how to enable the software-defined vehicle. So this is done by deploying domain-specific applications in a way which leverage features, for example, containerization, which SOAFEE envisions necessary to realize the software-defined vehicle. So an important aspect of a blueprint is for a user to be able to reproduce the blueprint on their end. So this is like information sharing between our members. And this then requires well-written and very clear documentation. So a user can consume a blueprint as it is, just replicating step by step for inspiration to see what other people are doing, or as a foundation on which to make modifications to suit their needs, making it their own. So here we can see a simplified view of a high-level architecture of a blueprint. So starting from the top, we have the domain-specific application. And in this context, domain-specific refers to some software which performs a certain task. The domain-specific applications are deployed using containers. The applications run on top of a SOAFEE reference implementation. On a high level, the requirement for reference implementation is that it enables the features which the SOAFEE architecture dictates. So using standards-based firmware creates alignment and allows a user to easily get an operating system up and running on any type of hardware which follows the firmware standard. An example of firmware standard is ARM's System Ready program, which is a compliance certification program based on a set of hardware and firmware standards. By enabling SOAFEE's vision of decoupling the software, possibilities for hardware flexibility arise. For example, at the edge is our embedded device, perhaps on a desk or in a car. Using the cloud gives us availability and scalability on demand as we need it to meet compute needs for intense testing. And one use of virtual hardware is to enable a user to deploy software on hardware that's not available. We all know the difficulty of getting a hold of hardware recently, or also hardware that doesn't yet exist in silicon. So the description of a blueprint is intentionally simple and quite generic, as we want to encourage SOAFEE members to create a blueprint the way they desire. So we don't want to put any unnecessary limitations on it. And please do visit the website, which is hosted on SOAFEE's GitLab to learn more about blueprints. You can see the link at the bottom, gitlab.com/SOAFEE/blueprints. So I hope this gives you a high-level understanding of the SOAFEE blueprints architecture. And next, I'll talk a little bit more in detail how we actually have used this architecture for the blueprint. So Autoware OpenAD Kit blueprint is the very first blueprint and has been a pipe cleaning exercise for everyone involved. It's been a bumpy ride, and I think we've now landed in a good place. So the OpenAD Kit is developed by Autoware Foundation, and the work done in the OpenAD Kit is done in the OpenAD Kit workgroup. The project aims to bring software-defined best practices into the open source autonomous drive software stack Autoware, for example, by introducing cloud-native development and production methodologies. The OpenAD Kit deployment model for Autoware is a microservices architecture with broad support for the cloud, the edge, and virtual hardware. The Autoware OpenAD Kit blueprint takes the output application workloads from the OpenAD Kit workgroup and deploys it in various ways, showing with practical examples how SOAFEE's vision of software-defined vehicles can be materialized. Up in the top right, we have a third-party application, and this could, for example, be a data collecting node or over-there updating service. The workloads are deployed in a Linux environment as containers or in an RTOS environment as needed. The framework provides a user with flexibility. So next, let's go into the details of the first version of the blueprint. So this is the very first version, version 1.0 of the Autoware OpenAD Kit blueprint. There are two different versions being worked on as well, version 1.1 and version 1.2, where changes to the deployment have been made. However, we've kept the containers as is. The blueprint is based on OpenAD Kit version 1.0 from the Autoware Foundation, which was released about a year ago now. Since then, a lot of progress has been made, and Christian will talk more about this topic later on. OpenAD Kit version 1.0 is built on 4 features from Autoware: map, perception, planning, and vehicle interface. It is running on EWAOL on an AVA developer platform. The AVA developer platform and the Linux machine are connected over Ethernet, and the Linux machine is running RBIS, which is our visualization tool, and Scenario Simulator, which is our simulation tool, which then exercises the OpenAD Kit software stack. Next, I'll jump into a couple more details on EWAOL. So Edge, Workload, Abstraction, and Orchestration layer, abbreviated EWAOL, is the SOAFEE Linux reference implementation. Okay, so what does this actually then mean? So EWAOL has features which enable the way SOAFEE envisions how software should be deployed. That is, in a containerized and virtualized way. Let's take a look at some of the pieces which make up EWAOL. So Docker is a container engine used to run containers. K3s is a lightweight Kubernetes distribution for container orchestration. And Xen is a type 1 hypervisor for hardware virtualization. So EWAOL is a custom Linux distribution built using the Octo project and is provided through the open source repository MetaEWAOL, which is under the SOAFEE GitLab umbrella. So if you go into gitlab.com/SOAFEE, and then you'll see there's a folder there called EWAOL, and that's where MetaEWAOL is hosted. EWAOL can be built in 2 different ways: bare metal, meaning that EWAOL runs directly on the hardware, and application workloads are run in containers. Virtualization, meaning that we can deploy virtual machines which run the application workloads in containers. These containerized application workloads are not part of EWAOL. You bring your own container. One of the benefits of the Octo project is its layer model development methodology, which is key to customization, and this enables users to take EWAOL and modify it to suit their needs. So in this blueprint, we deployed EWAOL at the edge on an AVA developer platform, and EWAOL has already been deployed in the cloud and on AWS Graviton instance in other contexts. However, this hasn't been implemented in the blueprint yet. By doing this, it gives us a runtime parity in the cloud and at the edge, which is very desirable. And this is thanks to the Octo project and that hardware vendors agree and implement standards-based firmware. We use the bare metal version of EWAOL, which makes it easy to deploy on the AVA and also in the cloud. We can see on the right that AWS has 3 different versions, or I've listed 3 different versions of the Graviton. C6G, which is the Neoverse N1 core, which is the same core as the AVA developer platform. G5G, which is the Neoverse N1 and also gives us a GPU-enabled instance. And then C7G, which is the latest one, which has a Neoverse V1 core, which has additional vector capabilities. So it has a bigger vector engine than the N1. So in the blueprint, we used the AD-Link's AVA developer platform, which has a chip from Ampere with the Neoverse N1 CPU. It's like a desktop developer machine with PCIe slots for acceleration, and it's really useful for prototyping. I'll now hand over to Christian, who will talk more about the autonomous drive application workload, Autoware and OpenAD-Kit. Over to you, Christian.
Thanks, Kasper. Next slide. Thanks. So just to start first with an overview of Autoware. This is an open source project managed by the Autoware Foundation. It's a complete autonomous driving software stack built on top of ROS 2 and openly licensed under the Apache 2.0 framework. It's a very modular architecture. So the different components of the autonomy stack, perception, planning, control, well-defined modules, APIs, built on ROS 2. So it really lends itself very well for a microservices type architecture. There's some useful links here about how to get started with Autoware and OpenAD-Kit. We lost the slides, Kasper. Thanks. Going on to the next slide. Just to give you an example of the types of vehicles that Autoware has been integrated. There's actually hundreds of projects around the world that are already using Autoware in various vehicle configurations, whether it's sort of small form factor mobility as a service shuttles, full-size buses, passenger vehicles. The flexibility of Autoware is you know, the modularity, the ability to adapt it and integrate it into different vehicles, the ability to modify the functionality within the different modules, whether it's perception, planning, or control for the particular environment that the vehicle is operating in. These are kind of all the strengths of the Autoware open source project that have allowed it to be adapted, integrated into so many different vehicle configurations, and deployed in different operational design domains around the world. So the focus of the foundation is really to develop this functionality as part of the open source project, and we've implemented various ODDs at a level of maturity that lends itself to start towards commercial implementations, such as operating in factory environments, cargo logistics, or shuttle bus type applications on predefined routes or private campuses. These are implementations of Autoware that the open source project and the foundation have been working on to implement in a more robust, well-documented sort of open source release. And we're starting to work on some of the more advanced use cases now that will in the future be implemented in the project around things like passenger vehicles and robotaxi type operational design domains, and that'll be coming in the next 1 to 2 years. Next slide, please. OpenAD-Kit is another aspect of the open source project that we've been working on that brings together several of the alliance partners of the Autoware Foundation. So Autoware Foundation, SOAFEE, eSync, and MIH are all part of this project, which we call OpenAD-Kit. And Autoware Foundation and MIH are both members of SOAFEE as well. The basic idea here is that we're taking the Autoware stack and implementing it on top of the SOAFEE EWAOL framework. Working with eSync, we are integrating their service as another sort of workload application within the framework and using that to do the management and updates of the Autoware application. And then in the context of MIH, where the focus there is to define an open EV platform and really define the specifications around the EEA and how the AD and ADAS application software interfaces with all of the other components of the vehicle, whether it's the sensors or central gateway, control plane, data plane functionality, infotainment system, and so on. All of these APIs are being defined within the MIH work groups, and then implemented as part of the Autoware stack so that companies can start to use the OpenAD kit as an out-of-the-box ready solution for implementing against the MIH specifications. Next slide, please. So where we are with the OpenAD kit today, as Kasper mentioned, we've released the 1.0 framework for OpenAD kit, where in this release, what we've accomplished is we've implemented Autoware within a container on top of EWAOL, integrated with the eSync OTA agent as another application within the framework. And we've demonstrated ISO level parity between running this framework in the cloud on an AWS Graviton instance and then at the edge on an Ava developer platform. But this is not really yet a real microservices architecture. This is the entire Autoware application running in one container. So there's still a lot of work to do to get this more towards the true vision of what a automotive workload looks like as a microservices application in SOAFEE. So next slide. The work that we're doing going forward now is really looking at how do we take this implementation of Autoware, take these modules, which, as I said, are really already kind of set up well in a ROS2 microservices type architecture, partition those into separate containers, and then implement that on top of the EWAOL framework. Also bringing in the capabilities that are coming in the releases of SOAFEE in the next year around hypervisor and hardware abstraction layers, so that we can build on top of heterogeneous compute platforms where there will be safety islands, where a safety capable MCU is integrated with high compute solutions such as GPU, CPU, dedicated acceleration logic for things like the perception and localization functionality, and making this all part of the OpenAD kit framework. And you'll see more from the Autoware Foundation on our plans to implement this on top of SOAFEE in the coming months. Next slide, please. Another important aspect of this OpenAD kit framework is, of course, the cloud native development. So providing the capabilities to work with this architecture and do the development and verification of the application in the cloud. So what the foundation is also looking at is all of the different tools and capabilities required to collect data from a vehicle, upload that to the cloud, do all of the ML ops, DevOps on the data as far as annotation tools, development of all the different simulation scenarios that have to be run to validate the application stack and the different functions within the stack, and then providing the different simulation tools that can be used, whether it's in the cloud or also on a test bench to do hardware in the loop simulation. So things like scenario simulators, sensor simulator suites, end-to-end simulators for the complete stack, and so forth. And then once the validation has been done in the cloud, providing the OTA capability through things like adding in the eSync client service to do the updates to the vehicle, and then start this whole process again of collecting more data and uploading it and validating the new functionality that gets developed. So I hope that gives you a pretty good idea of Autoware and the work that we're doing in the foundation around OpenAD kit. And hand it back to you, Robert.
Okay, thanks, CJ and Kasper. As Kasper said, this is the first blueprint, and we believe this is going to be really useful for people kind of getting involved with SOAFEE and being able to get to use SOAFEE.